Welcome to this session. In this session, we will try to understand transport layer. Have you ever wondered how does your phone know whether a message belongs to your WhatsApp, right? You have a WhatsApp, you have a Instagram, right? Once message came to your phone, right? How does it know that okay, this message belongs to Instagram, this message belongs to WhatsApp? How does this happen? Also, why does the bank transaction, whatever transactions you do via your bank, right? All money transaction never get corrupted. But the video call, whatever you are doing on your system, you will experience sometime glitches in that call. Why this happens? Also, there are multiple devices exist over the internet, right? How all these devices sends data here and there across the globe without mixing it up, how it is handled. Why do some apps need reliable delivery while other apps prefer speed over perfection? What magic ensure the Netflix stream continues even if some packet got vanished in the middle? How does all these things happen? Have you ever wondered? So this all magic happens because of your transport layer in the network. So without a transport layer, data would arrive without order. There will not be order in the data. Okay, without transport layer. Data packets, some of the data packets will disappear forever. You might not able to recover it if no transport layer exists. Slow senders, now few devices might be a slow sender, few devices will be a fast sender. So slow sender will never get a chance. At the same time, the fast sender will jam your network, right? Sometimes without transport layer, your app will receive wrong data. Downloads will become corrupted. Video calls will lag every second. All these things happen if there is no transport layer. So that's why in this session we will try to understand transport layer in detail so that you will get answers to all these questions, how it actually happens. So what does transport layer ensures? So transport layer ensures there will be a order, then reliability in the communication, then speed, then error tracking, then application level delivery. Your app is receiving the message, application delivery, then traffic control. All these tasks your transport layer does. Now, let us try to understand this magical transport layer. Okay, so we know, right? This is the OSI model, this is the TCP IP model, which we have seen. So, transport layer sits here. Okay, in OSI, it's here, and in TCP IP, it's here, just above the network layer and just below the application layer. So the transport layer is a delivery manager of the internet. It is also called as the delivery manager because it take data from one application. Okay, it take data from one application and deliver it safely, correctly, efficiently to another application across the internet. Okay, so it is called as the delivery manager. It is also called as a gateway between the end user and the network. So it's a gateway. Okay. So we have seen now where does it sit? It sits below application layer and above network layer. Now let us try to understand the key responsibilities of transport layer. So what are the responsibilities of transport layer? The first responsibility is it makes application connects or it extend application to network. Okay, that is its first responsibility. So what it does is it takes a message from your application, do its task in the middle in this pipeline, and then forward it to the network layer. Okay, that is its main responsibility. So it extends the network to the application. Then second responsibility is application to application delivery. So on one system you are sending the data from, for example, WhatsApp, and on other application, other system which is situated at the other end, receives the same data in WhatsApp, right? How does it possible? Transport layer. So application to application delivery is the task of your transport layer. Then third is segmenting the data. Segment the data. How does this happen? When you send the data, right, for you see data as a file, for example, right? For you, it will be a file. You upload the file for sending. Now, it's a task of the transport layer to split this data into the small segments of data, okay, and push it to the network. So all this data called as a segment, chunks called as a segment, okay, and these segments will be sequenced. It will be some sequence will be given to this, okay, so that when it receives at the other end, it will follow that sequence and club it, right? So that's what it does. Think of it like a big book sent in a multiple envelopes, each envelope numbered, so the receiver can assemble the book again at the destination, right? So that is what one of the responsibility of transport layer. The next responsibility is reliable and unreliable delivery. Reliable and unreliable. Okay. Reliable means you need to use TCP protocol. Unreliable means you need to use UDP protocol. So in TCP, all segments reach safely. Missing ones are resent. This we have seen, right? No duplicates. There will not be a duplicate of data, and the data receives in the correct order. A stable connection before sending. Okay. So if you are sending a message, it will be received in the same order, in the same sequence. Everything will be proper. So where TCP will be used? Banks, email, file download, web browsing, everywhere TCP getting used. Okay. Then there is a UDP. UDP is a fast but no guarantee of delivery. So UDP does not check whether the packets arrived, whether the packets has errors, whether it is maintaining the order, and it doesn't ask to resend the missing data. But it is extremely fast. Okay. So for what other purpose it is getting used? Live streaming, then online gaming, then video conferencing, VoIP calls, Zoom calls, Teams call, all this uses UDP. So this is also one of the responsibility of transport layer. Okay. Next responsibility is of fifth responsibility is of flow control. So what happens when there are the multiple devices connected to internet, right? Some devices are faster. Some devices might have higher configuration, higher resources. So those devices are faster. So they have a capability to jam the internet network, right? So that's where the transport layer comes for help. So it prevents the overwhelming a slow receiver. Okay. So for example, you have a faster system. This is a fast system, and you are sending it to the system which is slow. Now you are keep on sending the data, but this slow system cannot accept the data at the same speed what the sender is sending. So this management to make it such a way that the slow consumer can consume it, right? So that is a task of transport layer. Okay, transport layer. So for this, TCP uses the mechanism called windowing. Okay, windowing. Like asking, it will before establishing the connection, it will ask how many packets you can handle at a time. So the sender will ask the receiver how many packages you can handle at a time. The receiver says, okay, I can send me 10 at a time. And if I am busy, you send me 3 at a time. This avoids the congestion. So before only when the handshake happens, right, that time only it will ask the slow receiver how many packets it can handle at a time, and accordingly it will manage that. Okay. So one more thing, one next responsibility of transport layer is checksum. This is a very important. This is a part of error detection and correction. Okay. Now just think of you are sending a data from one location to another location. What is the guarantee that whatever you send went in the same order, in the same manner, and it is intact, not tampered in the middle? So how that will be make sure? The checksum make sure that. So checksum is, you can call it as a digital signature. Okay, it's a digital signature. It will be done at the sender side, and when it reach receiver, right, it will be verified whether it is still the same signature. It's like you are sending a packet, you have wrapped it properly, okay, and you are sending it to the receiver. Now receiver see the wrapping paper, right, whether it is tampered or not. If it is intact, right, in real life example I'm giving, if it's intact, then your data, your inside data is safe. Inside whatever gift or whatever material you send is safe, right? So that's how the digital signature work. Okay, we will understand this checksum in the upcoming session. Okay, don't worry about it, how it works. Okay, then next responsibility is your allowing multiple connection. Okay, so your one device can run multiple application, correct, and all the applications can talk to the other application situated at the other part of the world, and it happens seamlessly. How does it happen? Transport layer. We will see this one also. Okay, so next responsibility is multiplexing and demultiplexing. Multiplexing and demultiplexing. Okay, so how does it happens? So what happens is, now this is a user who access a multiple applications. These blocks are the application considered. These are YouTube, Facebook, everything you are running. Now you are, consider this is your network. Okay, so you are receiving the packets. Okay, so how does your system, how does the network, this is a network, right, how does your network know which data belongs to which application? This is happen, this it is able to identify it with the help of port numbers. Okay, so we have seen port 80 http. Okay, port 443 is https, port 53 is of dns, 25 is of smtp. So all these port numbers, based on this, it will identify the application. So what happens is, the transport layer uses source port and destination port to deliver data to correct application. So if I show you diagrammatically, it will look like this. Okay. So you have a application layer here. You have a application layer, you have a data. Okay. Now application layer is sending the data, right? It is running multiple applications. They are sending the data. Now here there is a socket plus port combination is used. Okay. So socket we have seen, right? So it's a IP plus your port combination. So that is a socket plus port. So we are just writing it here like this, right? So then here comes a transport layer. Now what happens? Application layer will send the data. The data will have a socket plus port defined. It will come to transport layer. Okay. Then transport layer will send it in a, it will multiplex. It will multiplex the data to different routes. Okay. And on the other side, right? What happens? Transport layer on the other side receives the data, and it will channelize it with the help of socket and port and figure it out from this data, the data belongs to which application, and accordingly it will send it. So this process is called demultiplexing. Okay, so this is what multiplexing and demultiplexing means. Okay, now let us try to understand the key features, some of the key features of transport layer. So first is TCP. TCP is a connection oriented. Okay, so connection oriented, it creates a long term connection between the host, okay, and the connection remains until a certain termination procedure is followed. Okay, so there is a termination procedure also. Okay, so if these are the two hosts, there can be a possibility that connection can be established with the help of transport layer. So connection oriented TCP. Then second is full duplex. Full duplex. So what does this means? TCP is a full duplex, which means that both hosts on the TCP connection can send messages to each other. So if we have two hosts, right? One can send to other can send to other. So to and fro communication is possible in transport layer. Other key feature of transport layer is point to point connection. So we have seen, right? It is one to one communication. It doesn't allow you to broadcast. So broadcasting is not possible in TCP if you are using TCP, right? In transport layer, if you use TCP, then broadcast and multicasting means you cannot do send to all, something like that, right? It's not possible in TCP. Then error control is one of the feature which we already saw as a responsibility. Error control. Then your flow control. These are also key features. Then congestion control. This one also we have seen, right? So these are all the features and key responsibilities of transport layer. There are few concepts which you should understand about transport layer that we will cover in the subsequent session. I will not make this session longer. So what all are we are going to understand in the next session is what is checksum, how exactly the data stay intact from one location to the other location, that we will try to understand. Then we will also try to understand how the TCP connection will be established. What is the process, right? The process is very strong, right? Not even a single data packet will get lapsed and it will be sent in the order. How this magic is done. So that is a connection establishment in TCP that we will try to understand in detail in the next upcoming session. Also, we will try to understand the TCP header. All this, whatever we are telling, right? All this is theoretical, but how does this actually happens? What is that procedure? How does it looks like? All these things that is called as the TCP header. For every message, whatever data packet which we are talking about, right? What the data packet looks like, so that it can perform all this point to point, error control, flow control. What are the provision made in the data packet? All this we will try to understand in the next session, that is the TCP header. This will be the session. So stay tuned. If you like this video, do share, subscribe to this channel. I keep on uploading such kind of videos which are interesting and I try to make it more interesting. So stay tuned.